Assalamualaikum, selamat malam.
Waalaikumsalam. Selamat malam, sir.
Mana yang lain? So can I start now?
Boleh sir.
Okay, check on. Okay, so Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera.
Waalaikumsalam.
Okay, so the topic today is under chapter 4. So this is the last chapter in EPO 553. So can you see my slide?
Boleh sir.
Ah? Tak nampak?
Boleh.
Nampak tak?
Nampak.
Pak sir.
Okay. So chapter 4, power system stability. Power system stability. Okay. So actually, what is the power system stability actually? Apa sebenarnya yang power system stability sebenarnya? Why we need stability in our system? Sebab apa kita perlukan stability dalam kita punya power system? Kenapa? Ada jawapan? Hello?
Hello.
Dengar tak? Dengar tak?
Dengar sir.
Kenapa kita perlu stability dalam kita punya power system? Sebab apa?
Stabilkan sistem.
Kalau tak stabil apa jadi?
Tak stabil.
Blackout.
Tu dia punya orang kata apa? Dia punya impact dia lah, tu kesan daripada kalau sistem kita tak stable lah kan. Betul tak? So dalam sistem kita sekarang ni yang penting kalau kita study yang untuk first chapter under ELD, right? ELD tu ada one term yang penting tu adalah reliable. Apa maksud reliable? Reliability. Reliable macam maksud dia macam bila kita nak deliver power, kita nak dia sentiasa ada. That means maksud sekarang kita nak dalam 24 hours yang kita ada. So TMB dia kena make sure that power will be delivered and then pada masa yang sama dia mestilah stable. Betul tak? Maksud stable sekarang ni daripada generation through transmission and then at the end ke distribution. So sekarang ni daripada generation, transmission and then distribution, kita nak power tu 24 hours mesti ada. Okay, tapi dalam keadaan yang stable. Stable mean without any problem lah. Without any problem. Itu yang kita nak. Maksud sekarang ni, bila kita power distribute, bila sampai ke rumah kita dapat 230 volt. Yang itu yang kita nak. Yang TMB hantar. Kita tak nak TMB bagi 100 volt ke, 200 volt ke, tapi TMB dia akan deliver power sampailah kat rumah kita in term of voltage punya supply 230 volt. That one kita panggil sebagai reliability. So pada masa yang sama we need the stability of the power system lah. That one we call that one. But sometimes maybe kita akan ada disturbance, right? So bila kita ada disturbance, one more thing, disturbance, itu ialah yang berlakunya yang you kata tadi, blackout. So bila berlakunya blackout, so reliability tu tak not 100% lah. Tak. Blackout ataupun yang saya suruh you guys buat satu cari info tentang outstage outstage. Sama juga lah blackout. So that is the reason lah. Itu sebab why kita perlukan stability dalam kita punya power system, right? Okay, so before that, so we can see the introduction here. Okay, introduction. So stability of power system. Okay. So power system ini our electrical lah. Okay, electrical meaning from generation, transmission to distribution. This is our power system. So stability of a power system is its ability. It is ability to return to normal or stable operating condition after having been subjected to some form of disturbance. That one we call as a stability. Stability of a power system is ability, kebolehan lah. Kebolehan kita punya power system untuk kembali ke keadaan asal ataupun beroperasi dalam stable punya condition selepas mengalami satu gangguan. Itu dah Malay lah. Kalau kita nak faham lagi detail kan. So ability to return to normal or stable operating condition after having been subjected to some form of disturbance. So disturbance means, so you have a lot of causes, and then maybe due to the lightning, due to the fault, okay, fault and so on. So conversely, instability means a condition denoting loss of synchronism of falling out of step. Okay, that means dalam keadaan mana sekarang ni? Yang dikatakan instability maksudnya keadaan yang mana sistem kita tidak dalam bukan dalam keadaan synchronize lah. Synchronize. Saya nak sebut begini. Synchronize lah. Synchronism. Or falling out of step. So falling out of step ni maybe they recall sebagai blackout lah. Ataupun kejatuhan voltage yang secara mendadak lah. Itu disebabkan gangguan. Right. So stability of a power system is a single phenomena. For the purpose of analysis, it is classified as steady state analysis and transient stability. So kita ada dua kat sini. One is a steady state steady state analysis and transient stability. So here given maybe the causes, okay, the causes here, so you can see here the causes. So this paragraph. So increase in load is a kind of disturbance. So one of the causes lah yang menyebabkan berlakunya ketidakstabilan kita punya power system, unstable disebabkan oleh increase in load is a kind of disturbance. Increase in loading take place gradually and in small step, and the system withstand this change and perform satisfactorily. So then the system is said to be steady state stability. So thus the study of steady state stability is basically concerned with determination of upper limit of machines loading before losing synchronism. Okay, so provide the loading is increased gradually is loading. Okay, so kat sini apa maksud machine kat sini Apa yang dimaksudkan machine kat sini? Apa yang you faham tentang term synchronize? Synchronize. Selalu kita cakap synchronize je. Apa maksud synchronize? Ada siapa boleh jawab?
Serentak ke?
Serentak. Lagi? Synchronize ni selalunya tersebut dekat mana sebenarnya selalu? Dekat mana?
Kat motor tu.
Dekat motor. Motor apa?
Synchronous motor.
Synchronous motor. Kalau lagi kat mana lagi? Kalau dalam sistem power system, selalunya yang you dengar yang kata kita perlukan sistem yang synchronize. Selalunya. Machine, apa maksud machine? Machine kita refer kepada mana? Kita refer kepada macam mana kita generate power? Daripada mechanical to
Electrical.
electrical. Right. So mechanical macam kita study dulu lah dalam automatic generation control. Macam mana electrical power boleh kita boleh produce sebenarnya. Right. So electrically, kalau contoh dia, kalau mechanical yang kita terbang and then kita rotate and then kita akan produce kita punya electrical. So machine yang masuk kat sini adalah merujuk kepada kita punya mechanical punya machine. Okay, machine kat sini merujuk kepada mechanical punya machine. So synchronize kat sini sebenarnya macam kita ada synchronize sekarang ni selalunya kita akan synchronize kita punya sistem kepada 50 Hz. That mean kalau you ada 10 orang kata apa machine pun dia mesti synchronize pada keadaan 50 Hz. Yang ni lah. So synchronize merujuk kepada apa? Yang tu yang kita kena tahu kat situ. Right. So machine kita merujuk kepada mechanical punya machine lah. Okay. Terbang lah maksudnya. Dalam case kita sekarang ni kita nak produce kita punya electrical power. So the way we try to produce electrical power, of course lah kita akan menggunakan kita punya mechanical machine. So the machine so now the machine we call as the mechanical machine lah. That one is turbine, right? Okay. So in practice, load change may not be gradually. So load change may not be gradual. So further there may be sudden disturbance due to. Okay, so here given the type of disturbance lah, we can call as the type of disturbance. Due to the disturbance, and then your system will be unstable. Okay, one is a sudden change of load, switching operation. Okay, switching operation, loss of generation, and then the last one is fault. Right, maybe loss of generation may be due to what? Loss of generation may be due to in case your generator unit, okay, we recall back to economic law dispatch, your generator unit will be collapsed, for example, under maintenance and so on. And then switching operation, normally the switching operation, that one is in a substation lah, for example. Okay, capacitor switching operation. Sudden change of load, okay, due to load demand, sudden change of load. So this is the list of the disturbance that can cause power system become unstable, right? Unstable. So once your power system unstable, okay, to ensure that the reliability of the power, so you must check, and then you must set your power system become stable from unstable, and then you do something in your plant or so on, and then your power system become stable. From unstable become stable. So what is the action so we must do to make it your power system from unstable to stable? So means unstable condition to stable condition. So what is the action? So we must, action must be taken lah. Okay, must be taken to ensure your power system become stable. Okay, so following such a sudden disturbance in the power system, roto. Okay, that's why I call this one tadi roto. Right, roto angular difference, rotor speed, and power transfer undergo fast changes whose magnitude are dependent upon the severity of disturbance. So here for a large disturbance, changes in angular difference may be so large as to cause the machine to fall out of step. So maksud sekarang ni apabila berlakunya disturbance, apa yang kita nampak adalah roto angular difference. Roto angular difference ni kita punya the rotating of the machine that we use. Okay. So pada keadaan disturbance yang agak quite high lah ataupun large disturbance, perubahan di dalam angular differences dia akan jadi lebih besar dan menyebabkan kita punya apa? Machine to fall out of step. So due to the fall out of step, so means our power system power system become unstable lah. Maybe can cause the blackout and so on. So this type of instability is known as transient instability. So for the first slide, you boleh nampak dia punya steady state stability, and then yang ni kita nampak dia punya transient instability. So transient stability is a fast phenomena. Yang ni transient stability dia memang keadaan yang memang pantas, usually occurring within one second. Dia mention kat sini 1 second for a generator close to the cause of disturbance. So generator close here means stop lah. Generator close to the cause of disturbance. So beza sekarang ni di antara steady state stability dengan transient stability. Right, transient stability. Kalau kita balik kepada yang persemua kat atas tadi tu, yang kita nampak apa? Kita ada dua kat atas, kita ada dua kat sini, kita ada steady state analysis and transient stability lah. Steady state stability dan transient stability kat sini. Okay, so here short circuit is a severe type of disturbance during a fault. Electrical powers from the nearby generator are reduced drastically, while power from remote generator are affected. So in some cases, the system may be stable even with sustained fault, whereas in other cases, system will be stable only if the fault is cleared with sufficient rapidly. Whether the system is stable on the occurrence of a fault depends not only on the system itself, but also on the type of fault, location of fault, clearing time, and the method of clearing. So kat sini dia kata sama ada sistem stable ataupun semasa berlakunya fault, dia bergantung bukan saja pada sistem itu sendiri, tetapi juga bergantung kepada type of fault. Yang pertama, fault punya lokasi fault, atau masa untuk clearing time, mean masa untuk kita clear the fault, and then the method of clearing the fault. So cara untuk kita clear the fault, okay, masa untuk clear dan cara untuk clear the fault. So this is the best statement here, right? So here, okay, so this is very important, so you have to know. So transient stability limit is almost always lower than the steady state limit, and hence it is much important. So transient stability limit depend on the type of disturbance, location, and magnitude of this disturbance. Right. Ni dia punya information lah berkenaan dengan disturbance and so on. Alright. So so the next slide, what? Okay, review of mechanic. Okay, review of mechanic. They want to be referred to the turbine operation lah. Turbine operation. So transient stability analysis involves some mechanical property of the machines in the system. So after every disturbance, selepas setiap kali berlakunya gangguan, the machines must adjust the relative angle of their rotor to meet the condition of the power transfer involved. Okay, yang ni sebenarnya kita bincang kat mana dulu? Okay, this one kita bincang dalam automatic generation control yang kita study dia punya what we call berkaitan di antara apa? Kalau masih ingat lagi, kita ada yang penting sebenarnya kita nak adjust apa? Frekuensi kan? Betul tak? Ingat lagi? AGC? Hello? Hello?
Ingat saya, ingat lupa.
So frekuensi dia akan berubah mengikut apa sebenarnya? Okay, yang kita study P1 plus P2 is equal to PD, power demand kan. Bila power demand increase, apa jadi pada frekuensi? Frekuensi jadi apa? Frekuensi akan jadi drop.
Demand naik, frekuensi turun saja.
Kita refer kepada kita punya ni. Ingat lagi tak? Kamu je lah. Ni kita punya frekuensi, ni kita punya power demand. Betul? Okay. So after every disturbance, the machine must adjust the relative angle. So maksud sekarang ni, apabila berlakunya perubahan dalam yang dikatakan power transfer involved ni, yang ni lah. Yang ni, bila berlakunya perubahan. Kat sini. So bila berlakunya disturbance, automatic machine will be adjust the relative angle of their rotor. So rotor angle ni memainkan peranan yang paling penting sebenarnya di dalam proses kita nak transfer sama ada kita nak increase the power ataupun kita nak decrease power, ataupun the way kita nak transfer kita punya power kepada kita punya power system. from generation to transmission. So the problem is mechanical as well as electrical. So bila berlaku ni dua benda yang paling penting akan melibatkan masalah di dalam mechanical dan juga electrical, right? So dia punya review of mechanical. So kalau kita betul-betul baca kat sini, kita nampak dia punya significant. Dia punya significant dari segi apa sebenarnya? Dari segi macam mana perubahan load demand di dalam kita punya sistem secara mendadak, suddenly drop, for example. Okay, tiba-tiba berlakunya blackout, and then kita boleh nampak perubahan ataupun kita punya any plan contoh kat Malaysia katakan tiba-tiba dia tak boleh support, tak boleh nak deliver power contohnya, itu akan menyebabkan perubahan load demand, load ataupun power yang kita nak deliver kepada kita punya customer. Tu isu dia kat sini lah. That's why betapa pentingnya power system stability sebenarnya di dalam untuk kita study lah. So di dalam in review of mechanics here, so you can see the kinetic energy of electrical machine is given by KE is equal to 1/2 I omega square. So the unit is megajoule lah. Okay, megajoule. So where I is the moment of inertia in megajoules, and then omega is the angular velocity in electrical degree per second. So angular momentum M is equal to I times omega. So from equation 1, so we can get equation 2, which is KE is equal to 1/2 M multiplied by omega. Okay, so M is equal to I times omega. Equation 2. So the angular momentum M. Okay, so the angular momentum M depends on the size of the machine as well as on its type. So kita tengok kepada size machine kita. So different machine, different dia punya orang kata apa? Dia punya what we call the best word is the power rating lah, the power rating, okay, the power rating ataupun dia punya jenis type of the machine. Okay, so the initial constant H. So now you have another parameter that we must consider is the initial constant H is defined as the megajoule of stored energy of the machine at synchronous speed per MVA of the machine. When so define the relation between the angular momentum M and the initial constant H can be derived as follow. So kita tengok apa dia punya relationship di antara H dengan speed and so on. So here relationship between M, momentum M and constant H. So by definition, H is the stored energy in MJ per machine rating in MVA. So now let G be the rating of the machine in MVA, G. Then stored energy is equal to GH mega. So stored energy is equal to G, the rating of machine. So now here the one is G. So stored energy in MJ by definition H times G. Okay, so machine rating MVA now we assume as a G. And then from here, from equation 3, so kinetic energy is equal to 1/2 M times omega. So M omega is equal to 2 pi to pi f, and then at the end you multiply this one, you cancel this one, you cancel this one, and then you get m times pi f megajoule. So from equation 3 and 4 here, so what we get? So m is equal to dh over pi f megajoule per second over a radian. Equation 5 here. Right, equation 5 here. So if the power is expressed in per unit, then G is equal to 1 per unit, and hence your M is equal to H over pi F, equation 6. So why the angular momentum M depend on the size of the machine as well as on its type. Initial constant H does not vary very much with the size of the machine. Dia tak berubah banyak. But the quantity H has a relatively narrow range of value for each class of machine. So but from equation 6 here, so what we can see is that the angular momentum N proportional to H actually. But M is inverse proportional to the pi F. So dia banyak bergantung kepada kita punya frekuensi. Nampak tak frekuensi kat sini? Betul tak? Frekuensi?
Betul sir.
Betul. Sebab tu frekuensi ni lah yang kita study dalam AGC. Perubahan pada frekuensi disebabkan perubahan dalam load demand. Load demand. Okay, load demand. So sekarang ni M ni yang memainkan peranan paling penting dalam kita nak control kita punya angle differences untuk make sure that kita punya system become stable. Nampak ni kat sini. Equation 6, equation 6. Okay. So dekat sini equation. Okay. So kat sini lah. Sorry. This one. Okay, ada apa nak tanya? Sebab apa? Ada isu lain nak tanya? Sebelum saya go to the swing equation. Nampak tak? Macam mana kita nak study sekarang ni?
Nampak sir.
Boleh ke sir?
Okay. Okay. So now I go to the next slide. Ada 3 benda yang penting dalam topik ni sebenarnya. Okay, we go to the swing equation here. So what is the swing equation? Apa maksud swing equation? So the differential equation that relates the angular momentum, okay, to the angular momentum tadi tu. Yang M is equal to H over pi F tadi tu. Okay. So the acceleration power TA and the rotor angle, dia panggil sigma or delta. Sigma or delta, dia panggil sigma or delta, is known as swing equation. The relationship sekarang ni kita nak tengok macam mana the acceleration power PA dan juga rotor angle delta is delta sigma, this one. Yang ni kita panggil apa ni?
Mana sir?
Ni.
Sigma tu sir.
Lambang ni apa?
Sigma tu sir.
Sigma kan? Sigma. Tak kisahlah. sigma ke theta ke, as long as kita faham rotor angle. That one just orang kata apa, dia punya simbol yang kita pakai je sebenarnya. Okay. Tapi yang penting kita nak tengok macam mana kaitan di antara kita punya angular momentum M, PA dan juga sigma tadi ni, rotor angle kita. So solution of swing equation will show how the rotor angle changes with respect to the time following the disturbance. So the plot of delta sigma BST is called the swing curve. Kita ada swing equation dan juga swing curve. So once the swing curve is known, the stability of the system can be assessed. Oh, sekarang ni kita tengok macam mana kita nak assess kita punya system stability. Okay, so the flow of mechanical and electrical power in generator and motor are shown. Okay, yang ni kita ada apa? Kita ada, okay, yang macam you tahu lah kat sini. Kita ada mechanical power. And then kita ada torque. And then kita ada omega. And then kita ada electrical torque. And then kita produce power. So consider the generator shown in figure 1A. It receives mechanical power PM at the shaft torque TS and the angular speed omega via shaft from the prime mover. Is deliver electrical power PE to the power system network there. So the bus bar, So the generator develop electromechanical torque TE in opposition to the shaft torque TS. So at steady state, okay. Maksudnya apa? At steady state, so shaft torque. Saya lebih suka menggunakan orang kata apa, shaft torque TS tu dalam bentuk PM. So kat sini saya boleh, tak kisah mana-mana tak kisah, TS ataupun TM is equal to TE. Dalam mana-mana operation, di dalam kita nak deliver kita punya power, so dalam sistem AGC sekalipun kita dah study dah kan, macam mana apa yang dimaksudkan dengan TM is equal to TE. So once TM is equal to TE means the one is at synchronized. Dalam keadaan yang synchronize. Dia dah mencapai keadaan synchronize. So bila at a steady state, that means synchronization punya condition. So if not, TS is not equal to TE, so unsynchronized. Maksudnya tak synchronized lah. So kita mesti synchronized dalam keadaan steady state. Dalam keadaan steady state, sistem kita akan synchronized apabila mechanical torque sama dengan electrical torque. Okay, that one. Okay, so now assuming that the windage and the friction torque are negligible, okay, dia punya assumption inside the what we call at the mechanical part. So in a generator, accelerating torque acting on the rotor is given by TA. Equation 7, TA is equal to TS minus TE. Okay, so multiplying by omega on both sides, we get equation PA is equal to PS minus PE. So in case of motor, TA is equal to TE minus TS. PE minus PS. In general, the accelerating power is given by PA is equal to input power minus output power. So you have PA is equal to TA omega is equal to I alpha. PA is equal to I times A omega and then M is equal to RA, M is equal to I omega MA, and then you get PA is equal to M D2 theta over DT2. So thus M DT2 theta over DT2 is equal to PA. So here theta here is the angular displacement in radian. So omega d theta over dt is angular velocity radian per second, and alpha here is equal to d omega over dt is equal to d to theta over dt2 is angular acceleration. So now we can see how the angular displacement kat sini. Okay, angular displacement theta here can be related to the rotor angle sigma here. So consider an object moving at linear blah 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 is required to find its displacement. So kat sini kita boleh nampak lah acceleration. Okay, PA is the acceleration. Betul tak? Accelerating power. Sama ada mesin tu dia akan accelerate ataupun decelerate bergantung kepada keadaan dia sebenarnya. Betul tak? Motor kita ataupun kita bagi sebagai the way kita nak increase kita punya output. Betul. So kat sini sebenarnya kita nak tengok macam mana kita punya sistem kita nak increase kita punya output power ataupun kita nak decrease kita punya output power. So sama ada kita increase, that one kita panggil sebagai acceleration. Kalau kita decrease, that one kita panggil deceleration. So dua term yang kita faham kat sini. So untuk in general, the accelerating power is given by PA is M times d2 theta over dt2. Right. Okay, so yang ni saya tinggal yang ni. So similarly in the case of angular movement, okay, so at the end, so we get equation. So that one we call as swing equation. Accelerating power PA equal to M, angular momentum M multiplied by d2 sigma over dd2. So theta sama lah, theta ataupun kita punya sigma. So kat sini kalau you baca betul-betul you akan nampak dia punya macam mana dia ubah angular displacement theta tu. So where sigma is the angular displacement of the rotor with respect to the rotating different axis which rotate at synchronous speed omega s. So the angle sigma is also called as load angle or torque angle. Dia benda yang sama kat sini. So just replace. So dd2 over d2 theta over d2 is equal to d2 sigma over dt2. So that's why it become equation 16. So the one is we call as, so the above equation is known as swing equation. Macam mana kita nak apply nanti swing equation sebenarnya untuk kita tahu untuk kita nak tengok sistem daripada stable, unstable kepada stable. Nanti kita tengok yang ni lah. Okay, so Sekejap kita tengok sampai mana. Kita stop kat sini tadi. Okay, kita bagi 3 slide lagi. Okay. So in case damping power is to be included, the equation 60 gets modified as m d2 sigma over dt2 plus d sigma over dt is equal to PA. So swing curve which is the plot of top angle sigma top angle and versus time can be obtained by solving the swing equation. So two typical swing curves are shown in figure 3. Okay, figure 3. Swing curve are used. Okay, apa gunanya swing curve? Why we need a swing curve? Swing curve are used to determine the stability of the system. So swing curve ni kita guna untuk kita tahu sama ada sistem kita stable ataupun tak. So if the rotor angle sigma reach a maximum and then decrease, then it shows that the system has transient stability. On the other hand, if the rotor angle sigma increase indefinitely, then it's shown that the system is unstable. Maksud dia apa? Kat sini, maksudnya saya draw lain yang ni. Maksudnya kalau kita tengok pada swing curve, swing curve ni dia naik and then dia drop, that one is stable. Tetapi kalau swing curve kita naik and then the naik increase drastically, drastic dia increase, maksud dia unstable and then yang ni stable. Okey tak? Macam mana daripada swing curve kita nak tahu stable tak stable? Okey tak? Clear tak?
Clear, sir.
Okey tak? Tak jawab pun.
Okey sir, okey.
Okey. Sekali lagi. Nak tahu stable tak stable? Tak tahu stable tak stable, kita main swing curve, dia akan naik in term of magnitude. And then dia drop. And then dia back. Dia mana this one? Yang ni kita panggil stable. Tetapi sekiranya kita punya curve kita dia increase and then drastically dia increase ke atas lagi, yang tu kita panggil sebagai unstable. Okay? Right. Okay, so here we are going to study the stability of a generator connected to infinite bus, and a synchronous motor drawing power from infinite bus. So refer to the schematic diagram here. So we know that the complex power is given by P plus JQ is equal to 1 times I conjugate. Is example P minus JQ is equal to V conjugate I. So thus the real power P is equal to V conjugate I. Is real lah. Faham itu. So consider a generator connected to infinite bus. Okay. Sekarang ni kita ada one generator through the transmission line and then connected to the infinite bus. So you ada V is the voltage at infinite bus. E is the internal voltage of generator. And then X is the total reactance. So X, the total reactance here is XD plus XT, right? So taking this as reference, V is equal to the magnitude of V at an angle 0. So phasor diagram can be obtained as V plus JXR is equal to E lah. Yang ni you faham kot. Okay, yang ni saya dapat yang ni So internal voltage E leads V by angle sigma here. So here internal voltage E is lead V by angle sigma. So E leads V, E and then you tengok V and the angle dia sigma, leading lah, E leading V. And then thus E is equal to E sigma, right, sigma. So current I is equal to 1 over Jx, so E cos blah blah blah. And then here what we can see is electric output power PE is equal to E times V over X sine sigma. So P max is E times V over X. So P max is sine sigma. Electric power. Masuk sekarang ni kat sini juga nampak E times V divided by transmission. Total reactance XD. So now your X is equal to XD plus XT, right? Total. And then you can get, okay, so from this equation, electric output power PE from generator here, so the maximum power will be delivered to the infinite bus. Dekat infinite bus nanti ni kita akan dapat maximum power dia adalah P max sin sigma. Okay, PE kat sini. PE kat sini kita akan deliver power to infinite bus. So E kat sini, maximum power dekat E ni, dekat sini sebenarnya adalah kat point ni lah, dekat point ni kita punya PE kita adalah EV over X sin sigma dekat sini. So power ni kita akan transfer ke infinite bus melalui kita punya transmission line. Transmission line kat sini ataupun total reactance kat sini XD plus XT. Okay. Okay, so now consider a synchronous motor drawing power from infinite bus. So internal voltage E lagging the terminal voltage V by angle sigma. E lagging V, and then here the E is the magnitude E, angle minus sigma, and then current. So electric input power PE is equal to P max sin sigma. So benda yang sama sebenarnya yang nampak. Okay, this one and then this one. So thus swing equation for alternator is M d2 sigma over dt2 is equal to Pm minus P max sin delta. Swing equation for motor is P max sin sigma minus Pm. So notice that the swing equation is second order nonlinear differential equation. Sini yang kita nampak apa? Yang ni apa? Generator. Yang ni motor. Dua benda yang beza lah. Tapi kita mostly kita akan concentrate on generator. Okay, generator. So nanti kita tengok one by one dia punya isu kat sini. Okay, so any question? Ada soalan nak tanya?
Tak ada sir.
Tak ada. Ada. Hari ni 5 bulan 1 2021. Okay. Ada nak tanya apa-apa? Boleh baca balik lah. Baca balik, faham balik apa yang saya cakap tadi. Hopefully boleh faham detail berkenaan dengan nota yang ni. Ada 2-3 isu lagi lah yang kita nak discuss. So insyaAllah lah kita boleh siapkan lah. Kita boleh habiskan dalam masa yang terdekat nanti. So you tengok equal area criteria ni. Macam mana saya pun tak nak detail ni sangat. Nanti ni boleh insyaAllah. Okay, so saya minta you all tolong tengok equal area criteria. Okay, ada ada 3 topik yang besar ya. Swing equation, equal area criterion, dan satu lagi step by step solution. Macam mana daripada step by step solution tu kita boleh calculate kita punya roto angle. Yang tu pada nanti insyaAllah tak ada apa-apa. Okay kan? Hello.
Alright sir, alright.
Alright so saya semua boleh faham apa yang saya cakap ni lah.
Dia formula je sir. Dia pakai formula je lah.
Pakai formula je. Dia banyak pakai formula sikit. Nanti saya akan bagi F4 dalam Word 2-3 soalan. Tengok nanti saya mana. Hilang lah. Okay, so kalau tak ada apa-apa, terima kasih banyak-banyak. InsyaAllah kita jumpa hari Khamis. InsyaAllah. Okay
Okay sir.
Boleh sir, boleh.
Okay sir.
Terima kasih. Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.